shouldn't worry about the next couple of weeks, because guess what? We're going to spend time drawing pictures. That's what you're going to be doing in math class. You know, one of the first things you learned probably in first grade was sets. And you studied about sets, and that's what we're going to be looking at. Relationships between many sets. It's going to get complicated, and the tool we'll use or the tools are these animals' Venn diagrams. But let's look at the basics of sets. What is a set? A set can have any objects in it at all. It has to be, however, a well-defined collection of different, distinct objects. We call them the elements of the set. And they get picked out of the universe. We'll always use a capital U for that. You only get to pick elements out of the universe of that problem. Okay, and we'll always define the universe for you. Okay, here's some examples. Set A, set B, set C, set D. And we'll always put sets in French brackets. Now, the elements of a set are the members. And we have a symbol for that. This is red, it's an E. 3 is an element of A. And as you can see, 3 is an element of set A. Consequently, we're going to have another symbol, not an element. For instance, 3 is not, the cross out means is not an element of set C. And as you can see, it isn't. Okay, it's okay, it's just that's the statement. Is an element and is not an element. Now we're going to count how many members or elements are in a set, and there's notation for that. For instance, n of A is the number of elements in A, in set A. And the number of elements in set A, 0, 1, 2, 3, is 4. There's 4 members. They happen to be numbers. The number of elements in B, as you can see, is 5. The number of elements in C is 2. Get the idea? Now, we're going to have another word, subsets. A set A is a, quote, subset of B if every element of A is also an element of B. Now, I try to remember that symbol, the fallen down U, as a C. In other words, A is contained in B. Means A is a subset of B. A is totally contained in B. Okay? So we would say C, set C, is a subset of set B. And as you can see, the 1 and the 2 are totally inside of B. So C is contained in B, or C is a subset of B. D is a subset of B. You can see that 3 is contained in B. It's a subset. It's a part, kind of. This would be read, B is not a subset of C. B is not totally contained in C. As you can see, it's not. It has to be completely. It only takes one to screw it up. Okay? Now, let's talk about an intersection or intersections of sets. The definition, A intersection B, and that's the upside down U. That's A intersection B, is a separate set. It's a set of elements of all the elements that belong in both set A and at the same time also belong in set B. Let me see if I can give you an example. The intersection of A and B is 1, 2, and 3. Now look at set A and look at set B, and they both have 1, 2, and 3 in them, don't they? The intersection of A and set D is the single element 3. If you look at set A, you see the only thing that's in A that's also in D is the 3. So the intersection is the set that contains the member 3. What about the intersection of C and D? Well, let's look at C and look at D. And the intersection is, well, nothing, but it is a set. So we say,
I don't understand.
Well, all the members that are in set C and in D, and there aren't any members that are both in set C and set D. So we say the intersection is the empty set. Okay? Speaking of the empty set, what the heck is an empty set? Empty set is any set that has no elements. And there's a symbol for that. Okay? No elements. Now, I don't mean it has 0 in it, because 0 is something. Okay? It has no elements. The intersection of C and D is the empty set.
There's something screwy around here.
This is not the empty set because it's not empty. It has something in it. Okay? It has no members.
Now then, boy, we'll see how much you learn.
Well, if you know what the empty set is and you know what that little n stands for, what is the number of members in the empty set? You got the, it's kind of confusing, isn't it? The number of members is a number. Okay? Okay, now let's talk about probably the most difficult of all is unions. The union of A and B, read A union B, and written out A U, that's actually a U, B, is the set of elements that belong in either set A or in set B. They don't have to belong in both. They can belong in both, but either A or in B, and we never write anything twice. So for instance, A union B is going to be all the numbers in A and all the numbers in B. Now notice 2 and 3 are in both, but we don't list them twice. So the union of A and B is 0, 1, 2, 3, 5, 7. See? The union of A and D is going to be 0, 1, 2, 3, and D really didn't add much to it because it was already there. We don't write it twice, so it's 0, 1, 2, 3.
I know that, dude.
Don't list anyone twice, okay? The union of C and D is just put them together. 1, 2, 3. That's easy, okay? Venn diagrams can actually draw pictures of sets, and that's what we're going to be doing. Pictures of way more complicated sets than C and D and whatever with the little numbers in it. Every Venn diagram is going to have a universe. Now, actually, it doesn't go to infinity, but as far as we're concerned, that's as far as we're going to go. That is our universe. Your universe may just be your house. It may just be your room. Or, who knows, may be your classroom. That's as far as you go. Okay? That's the universe. And it'll always be drawn with a big U inside a rectangle like this. Any of the sets that we try to represent will be typically circles with capital letters. For instance, set A and set B, and there can be other circles, okay? And they may touch, they may not touch, kind of a deal. Now if I try to draw a picture of A unioned with B, I want everything that's in A, right? A union B. It's everything that's in the universe that is either in set A or in set B. Now it can be in both. I didn't say anything about that. But either in A or in B. And I hope you appreciate that's what it's going to look like if I shade in A unioned with B. I shaded in all of A and all of B. And notice where they touch, I didn't shade it twice. Okay, so that's A unioned with B. The intersection, written A intersection B, I'm going to have to shade everything in the universe that is both in set A and also in set B. Now that's a much smaller area. What area is both in set A and in set B? See the difference between that and the union, I hope. Now, when we get to the more difficult problems, we're going to want to involve some other concepts. For instance, a complement. A complement, written like this, a, and that little apostrophe kind of thing, is complement. It's going to be all members in the universe that are not in A. Everything but A is kind of what you're talking about here. Everything not contained in A.
That's so easy. I should have thought of it, boy.
Notice that I only get out as far as the universe. I don't color in the whole, out on your desk and out to the next person's desk and so forth. We only go as far as our universe. So that's a complement.
Played it for her, he played it for me. Play it.
Okay, well, do B complement, just so you get the idea. Okay, written B complement. Of course, that would be everything in the universe that is not contained in set B. Pretty simple. Just shade in everything, but don't shade in B. Okay?
I'm trying to think, but nothing happens.
Okay, now we'll put the two together and see what we would get. Now remember, in all of math, you do what's in parentheses first. So anyway, this would be read or written A union B, figure out what that is, and complement means draw everything else. So you gotta get in your mind, what's A union B? Do what's in parentheses, look at, and don't shade it yet, A union B, and then fill in or shade in everything but that. You're shading in everything that is not contained in set A or set B, because set A or set B is the union of A and B. It should look like something like that. That is A union B complement. Everything but A union B. Get the idea? Let's try A intersection B complement. How would we write that first of all? Yeah, just write A intersection B. Remember the intersection. I always remember the union is the U and the intersection is the other one. Okay? The upside down U. So figure out what the intersection would be and then do everything but the intersection. Everything not contained in both set A and set B. It's going to look like that. Remember where the intersection was and you wanted everything but that. Okay? It's going to get more complicated as we go on.
And now something completely different.
Let's talk about difference or subtracting sets.
Just as I suspected.
The difference, or we say B minus A, is the set of all the elements of set B that are not in set A. In other words, A takes a bite out of B, if you would. Show you what I mean. All the members of B that are not in A. See the bite it took? Those are all the parts of A. Okay? So that is B minus A.
Then you'll come again.
Let's do another one. What would A minus B be? The set of all the members of A that are not elements of B. See, not so bad, is it? All the elements, that's A minus B.
No, I can't take it. I can't take it, Jerry. It's too much. It's too
Oh, well, if you understand the concepts, I hope they were easy up to this point. Let's try it with 3 sets at a time.
Oh, right
There's my universe. We'll call that set A, that set B, and that set C. Okay? What would A intersection B? I didn't say anything about C, so you can, for right now, you can forget about C. Just A intersection B. Everything that's in A and also in B.
Hey, man, check it out.
Yeah, that's just the way it was before, isn't it? Okay, now we'll switch the letters. Let's forget about A, and do B intersected with C. Okay, so just look at B, concentrate on B and C, and what's in both B and C? The set of all members, just in the universe now, that are both in set B and in set C.
Any of this sinking in, boy?
Get the idea? You say, well, geez, Woody, you're still only working with 2 at a time. Let's stay with me now. We're going to get complicated pretty soon, but I want you to understand this very well. So A intersected with C would mean forget B. And just give me all the members in this universe that are both in A and in C. Okay, very simple, isn't it? That's the intersection of A and C. Well, what would the intersection of A, B, and C be? In other words, I need all the members in the universe that are in A, and they also have to be in B, and they also have to be in C. Think about it. That's the only portion that's in all three, isn't it? A, B, and C. That's what it means to be the intersection of three sets. What do you think the union of A and B? We did this already. All you have to be is in A or B. Okay, that's easy. And B union with C, all you have to be is in B or in C.
Excellent.
Okay. And A union with C, all you have to be is in A or in C. You just have to pay attention to what the letters are. Okay? Okay, now let's try all three. A union with B, union with C. Well, all you really do, you think about it, is put them together. Anybody that's either in A or in B or in C, this is going to be easy. As long as you're in one of the three.
How do I do it?
There it is. Okay, now there's an area on the outside there that isn't shaded in the universe. That's because that area isn't, there's nothing out there that's in A or B or C. It has to be in one of them to be in this union. Okay, now, how about do what's in, we just did A union B union C. What would A union B union C complement B? In other words,
just remember that this thing isn't as black as it appears.
this isn't that bad. Wait a minute. Everything not contained in A union B union C. So kind of imagine A union B union C and shade everything else. That's the idea. Very good. Now I hope you appreciate we're sneaking up on you here, making it complicated a little bit at a time. If I had given you this one about 10 minutes ago, you might have fainted. So we're sneaking up on you. How about this one? I want you to do what's in parentheses first. A union with B, do that in your head, A union with B, and then subtract anything in C from that. A union with B,
Is that your final answer?
no, we're going to subtract anything that's in C from that.
You're absolutely correct.
And that's the answer. Kind of wild, isn't it? This is going to be useful. I'll show you how in a little bit.
Something's happened to my brain. It's all dried up.
Wait a minute. How about A intersected with B and then subtract C? Got to do what's in parentheses first. A intersected with B. We're not done yet. A intersected with B. Now subtract anything that's in C away from that gray area. And that's the answer to the final answer. Okay?
How about little fires, Scarecrow?
Holy, go to war. I might take a couple pictures to do this, Billy. I want to show you some methods that you can use when it gets really complicated like this. Okay? I call this the check mark and shade method. Okay, see if you can see what I'm doing here. Certainly I'm going to do what's in parentheses first. A union with B. So let me check all the sections as if it's a paint by number for A union with B. That part, that part, that part, that part. I would have shaded all those parts for A union with B. Okay? Now let me work my way to the outside. All I've done now is A union with B. Now I want to do everything but that. Well, I'll tell you what. Let me draw another picture and do everything but that. Okay? That's going to be everything but that. You could have used check marks if you wanted to. I just happened to shade. Okay? Now, I want to intersect that area with C. What portion of what I've drawn here in the second picture is also in C? You can see where the check marks are going to come into play here. I need different colors, and sometimes a check mark just acts as a different color. So that's the area. Okay? Just that one portion where it's yellow and check marked. Now, is that my final answer? I don't know.
Not because they are easy, but because they
Sometimes these are tricky. I'm supposed to subtract B from that. Well, in that yellow area, there isn't any portion of B. Sometimes an operation has no effect. So don't think, you're doing it wrong when you think you know what you're doing. You probably do. Okay, so to subtract B doesn't have any effect in this case.
You've absolutely proved to yourself and to the audience that you deserve to be in this competition now.
And that is the final answer there. Okay, very good. Look at this one. Holy, this is a check mark multiple picture for sure. Okay, that's A minus C. A take away C is going to be this. All right, I got A take away C. Let me do the other one. C complement. I'll do another picture for that. C complement is this, and I want to intersect that with B. C complement intersected with B. What's drawn and also in B is that area. See how we're using the check marks and colors? Okay, so that's that. Now that's the two sections, and I want to union.
Now what am I gonna do?
I want to union those two pictures together. So basically I shade what's in both pictures. That's the first picture. And that's the second picture. I did have some overlap, but I don't shade it twice. And there it is. That's my final answer in that case. It's quite complicated, isn't it?
Does everybody know what time it is?
Well, I'm going to ask you to do some on your own. I don't think I'll give you anything more complicated than what I did. But remember the check mark and shade method, and don't be afraid to draw multiple pictures, and always do what's in parentheses first. Okay.